Hello students, today's agenda is to check homework. We'll be learning about length to volume proportions and you will be able to do 11.11. Today students will be able to use proportions of lengths to volumes. For number 1, it says the sides of these two cubes are the same. 3 meters, 3 meters. If you know the volume of one of them, can you find the volume of the other? Well, because they have the same dimension, we know that it's going to be the same, right? 27 cubic meters. And from previous lessons, we have learned that for the volume of a cube, you multiply length times width times height, and that's just any rectangular prism, or for the cube is just 3 cubed. Okay, so 3 times 3 is 9, times 3 is 27. Now, let's say that the sides of the second cube is twice as long. So each dimension is 6 times 6 times 6. If this is twice, we would assume that the volume in here would be twice. But in reality, 6 times 6 is 36, times 6 is 216 cubic meters. That's not twice 27. Twice 27 will be 54, but the volume in reality is 216. So what is the relationship in here? Well, this is times 2, right? 1 to 2, okay? So 3 times 2 is 6, but what is the relationship in here? To find that out, we can divide 216 divided by 27, and we find out that it's 8 times. The relationship between these two is 8 times. How do these two compare? How do we get to 8 from here? Well, something that I want you to notice is that we have a 3 in here. If we take the cubic root of 8, that's going to be the 2. Or if we raise 2 to the third power, then 2 times 2 times 2 is 8. So that's the relationship in here. That in here, for the sides or length, we cube it. We raise it to the third power. But in here, when we have the relationship between the volumes, volume, which is cubic, we take the cubic root of whatever relationship is between that. Okay, have that in mind because that's going to be very helpful. Number 3. Now, the sides are 3 times as long. By looking at the previous example, we know that this is not going to be times 3. So I want you now to think about it just by looking at the relationship that we saw. Okay, 9 divided by 3 is 3. So that's the relationship between this. So 1, 2, 3. What is the relationship in here? Again, we divide 9 by 3 to get this 3. Now, because we want volume, we're going to raise that to the third power. And that gives us 3 times 3 times 3 is 27. Okay, so that's the comparison or ratio between these volumes. What do I do? I just multiply 27 times 27. And so 27 times 27 is 729. So that's how we're going to be doing this. Again, we will divide the two values that we have. That's going to be our ratio or comparison between those two. Then, if what we have is length, we raise it to the third power. But if, let's say that what I was missing is one of the lengths, what I'm going to be doing is dividing this and taking the cubic root of the comparison of the volumes. So these are the two numbers that are key. We're going to be able to find one by dividing the ones that we have. We'll find the other one either by raising to the third power or by taking the cubic root and getting the other ratio. And then from there, I'll show you. And you know what? The way that you can do it is that we see, 3 to 9. That means that the proportion is 1 to every 3. 1 to every 3. And then in here, what we're going to do, because it's cubed, all we have to do is raise to the third power. So it's going to be 1 times 1 times 1 is 1, 2, 3 times 3 times 3 is 27. Okay, that's the way you can see, oh, that for every one that we have in here, we are going to have 27 in here. But because we have 27, we just multiply that. I will show you some steps that you can take if you get confused with using this proportion. The other way is that, what if we're missing this? What we do is take the cubic root of this, and then the cubic root of 1, well, 1 times 1 times 1 is 1. And then what number multiplied times itself 3 times is 27? Well, 3 times 3 times 3 is 27, so that's why that will be the answer right there. Okay, those are the way they relate lengths with volumes. For number 4, it says, what about now? The sides are 4 times as long. Why? Because 3 times 4 is 12. But we notice that 27 times 4 is not this amount. It's just 108. What do I do? Well, how did I get this? Because in here, they're telling me. Well, all I have to do is divide 12 divided by 3 is 4. Okay, that means that the ratio is 1 to every 4. And in here, well, cubic. When it's going from length to volume, you have to cube that. And 4 times 4 times 4, 4 times 4 is 16. 16 times 4 is 64. That's the relationship between these two, or the ratio. So in here, we're going to say that is going to be 1 to every 64. How did we get that though? We divide this, we get the 4, so we say 1 to every 4. Because it's length, we raise it to the third power to get volume. Volume is cubic. And 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. Okay, or you can just do it in here directly. 12 divided by 3 is 4. Raise it to the third power. 4 times 4 times 4 is 64. That's the relationship between these two. What does that mean? That if sometimes I'm going to be missing this number, sometimes I'm going to be missing this other number. If what I'm missing is the tiny one, I have to divide going that way. 1728 divided by 64, and you will get that amount. But if what I'm missing is the big one, the big volume, then I'm going to multiply from the tiny times the ratio equals the big volume. And you can see here, 27 times 64 equals, there you go, 1728. Now what if I'm missing this volume? 1728 divided by 64, it's 27. Again, the steps, and I'm going to write it down. The steps is divide the big number by the small one. Okay, so step number 1, divide big divided by small. And then sometimes what you're going to have is the 2 in here and missing one of the lengths. You're going to take the cubic root if what they're giving you is the 2 volumes, but missing one of the lengths. Okay, you're going to take the cubic root if you're missing one of the lengths, but you're given the 2 volumes. These are the 2 volumes. Okay, however, if what you're dividing or what they're giving you is the 2 lengths, then you're going to raise to the third power. Okay, raise to the third power. And finally, you will divide if what you are given is the big measurement, or you're going to multiply if what you're given is the small measurement. This will make more sense when we start doing them, but at least you get an idea of what the ratios mean. Okay. In your assignment, this is what they're going to look. And these are going to be different. Don't pay attention to the figure. Just look at the lengths and the volumes, okay? That's what matters. Okay, so we're looking here. We're missing one of the volumes. What we're given is the lengths. If you want to follow the steps, write them and have the flashcard in front of you. The first step says divide big by small. So well, I'm given the 2 of. In here, they're giving me the 2 lengths. I'm going to divide those. 4 divided by 2 is 2. Because it's length, but I need the volume proportion or ratio, I'm going to raise this to the 3rd power. I tell my students, if he doesn't have a cube, put the cube. If he has a cube, take the cubic root. Again, this is because these are lengths and I need it into volume ratio. 2 to the 3rd power means 2 times 2 times 2, which is 8. So over here, it was twice as big. So 1 to 2. I raise it to the 3rd power, right, to get it into volume. And so 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. So that's that comparison right there. The other thing, so what did we do? We took this one in here, raised to the 3rd power, because what we were given were the lengths, raised to the 3rd power. The 3rd step is to either divide or multiply. If what you have is the big measurement, you divide to make it tiny. But if what you're given is the tiny, you multiply to make it big, okay? So look at the 2 figures, or even compare it in here. What you're given in the volume is the tiny, so what are we going to do? We're going to multiply. And 16 times 8, 16 times 8 is 128. So x equals 128 cubic meters. Okay, so that's the volume. Be careful because see, I could have moved this figure over here, so it doesn't mean that if it's on the left or the right that's going to tell me the either the multiplication or division. It just means if what the number that you have is the tiny figure, you multiply. If I had this volume initially, then I would have to divide to make it into the small amount. Number 2 says solve for x. Now I do not have the lengths. What I'm given is the volumes. I still do the same thing. I'm going to divide the big amount by the small, or the big volume by the small volume. So 100 divided by 30. And you can leave it as a fraction or you can leave it as a decimal. If we decide to do it as a fraction, I'll do both actually, even if the video is a little longer, but that's okay. So I'm going to use 3.33333, 3.3 forever. Now in here, something that I want you to notice is that the relationship or ratio in here is between volumes. I say, if you have the cubic, cancel it. So when you don't have the cube, like in number 1, you put it. When you have it in here, in the measurements that you divided, when you have that cube, you take it away. How? With the opposite, which is the cubic root. Okay, what is the cubic root of 3.3? And you can just leave it like that. By taking the cubic root, now you have the ratio or relationship between lengths. Okay, I made a mistake. I was pressing the square root in here, but it's cubic. So let's be careful with that. So in the calculator, this is how you're going to do it. You're going to press the 3, and this is in some calculators. So 3 and then shift, and then you'll see that that root with the x. Let me show you right there. So you're going to use shift and press this key to get that function. Okay, so again, shift, and that's what it's the cubic. And then you just press 3.3. And you can do a couple of them because you saw that it was 3.33333 forever. And so the cubic root of that is 1.49. Okay, 1.49. And so what do we do with this? Again, the last step after we take either the cubic root or raised to the third power, we have to either divide or multiply. Which figure do I have the measurement of? The big one or the small one? Do I have the big length or the small length? By looking at the volumes, I notice that I have the big length. Okay, and so what do? I'm going to divide. If it's the big one, we divide. So in here, divide. And we divide this by the ratio, not the ratio by the length. Whatever they're giving me, by the number that I found. Okay, so 3 divided by 1.49, it's 2.01. So you can either put 2.01 or just if you want to round it to the wholes. Okay, and it's going to be meters. Okay, so these are going to be my measurement. So X equals 2.01 meters. And I know I'm repeating myself a lot, but what are the steps? Divide the two numbers that I have. If they are the volume, you take the cubic, right? If it's cubed, if those measurements are cubed, the opposite is to take the cubic root of whatever you got by dividing. After you take the cubic root, you write the answer in here. And with that number, you're going to either divide if you're given the big one, or multiply if you're given the small amount. Now, what if I decided to do those steps but in fractions? First step is the same. Divide big by small. So 100 divided by 30, and we cancel because 100 divided by 10 is 10. 30 divided by 10 is 3. So we end up with 10 thirds. After that, we know that those are volume. Those are cubed. So the opposite is to take the cubic root. And in our calculator, this is how you would do it. Since this will be more exact, let me show you what the answer would be. So basically, you cannot simplify that anymore. So that's what your ratio would be in here. By taking the cubic root, you just put that in here. And then divide 3 divided by this amount. Okay, so let me write it down. 3, which is this length, divided by the cubic root of 10 over 3. So you put in the calculator so that you can see it. 3 divided by the cubic root, you just put the 3, shift, and the root with the x. And then between parentheses, you're going to put 10 divided by 3 and close your parentheses. Okay, because it's one operation inside of the cubic root. That's why you need those parentheses. And then you press equal. 2.008, 2.008, the 8. So let me write it in here. 2.008, the 8 makes this go up 1. Okay, we rounded, we got rid of some decimals. So that's why this is a tiny bit smaller, but very, very tiny difference. And again, you can work with either decimals or fractions, whichever you prefer. Okay, here for the last example, we have weight is directly proportional with volume. So weight is always in grams. Centimeters is length, how long something is, but weight is how much it weighs. And this is always cubic in relationship to the length, okay? Just like volume, basically. We don't use the cubic, however. In grams, we don't put cubic, but if you need to, remember, oh, that's like cubic, like volume, okay? Okay, so now it says find the weight of the larger rock. Again, what is it that we're given? Oh, we're given length. So what is the ratio? It's 1 to 2, right? Because 20 divided by 10 is 2. That's the ratio or relationship. Because it's length, what do? The second step, when we're given length, we raise to the third power. We cube it. And that will give us the ratio or proportion between the weights. 2 times 2 times 2 is 8. Again, if you need to see it, this is 1 to 2 because it's twice as big. The weight is 1 to 8. We just cubed that. And so, what do we do now? Well, this is smaller than this one in length. That means that I'm going to, if I have the small, I'm going to multiply. That's for the third step. So multiplying here, 1,500 grams times 8. 1,500 times 8 is 12,000. Okay, so 12,000 grams. The weight is 12,000 grams. That's how heavy that stone is or rock. With this, we end our lesson. If you can please give us a thumbs up, subscribe around here. This is the link to the entire unit. Here you will find the next video. To follow us on TikTok as Math Maria 7. Follow us in Facebook in the group Mathematics and Life. Now you're able to do 11.11 and have fun.
Have fun.